Hello, friends, and welcome to this episode of Stars in the Sky. Today, we're going to take a look at Alpha Centauri, which is the closest star to Earth. On a clear night, Alpha Centauri can always be seen from the southern hemisphere. It can even be seen with heavy amounts of light pollution. Alpha Centauri is part of the constellation Centaurus. Alpha Centauri can be found using the Southern Cross. First, locate the Southern Cross. Then, locate the two bright stars near the cross. These are known as the pointer stars. Alpha Centauri is the pointer star that is farthest away from the cross. It is the brightest star in this region of the sky, so it will stand out. You can also use the Coalsack Nebula to orient yourself. This is a dark spot near the Southern Cross. Alpha Centauri is the third brightest star in the night sky. Alpha Centauri is not a single star, but a three-star system. To the naked eye, two of these stars blend together as a single point of light, while the third one is too faint to be seen. The distance to Alpha Centauri is roughly 4.34 light years. For nearby stars like Alpha Centauri, we can use what is known as stellar parallax to calculate their distance. This is an amazing technique. Let's take a look at how it's done. For our calculation, let's just consider one of these three stars, Alpha Centauri A. From January to July, Alpha Centauri A traces a tiny little arc across the sky if you compare it to the backdrop of distant stars. It shifts by about 0.751 arc seconds. This is an extremely tiny shift. But why are we measuring this shift with arc seconds? The sky is mapped like a giant sphere around the Earth, divided into 360 degrees. Each degree is divided into 60 arc minutes. Each arc minute is divided into 60 arc seconds. That means 1 degree is 3,600 arc seconds. And hence 1 arc second is 1/3600th of a degree. It's a razor-thin angular measurement. And this is perfect for measuring tiny little shifts, like the ones caused by stellar parallax. To figure out the distance to our star, we can think of it as we are trying to solve a right triangle. We already have the angle, which is our stellar parallax. And as it turns out, we also know one side of the triangle we are trying to solve. It's the length of one astronomical unit. An astronomical unit is the average distance from the center of the Earth to the center of the Sun, which is about 150 million kilometers, or 93 million miles. This gives us a dependable baseline for calculating the distance to our star. With this one angle and one side, we have everything we need to solve our right triangle. We can solve the rest of our triangle using SOHCAHTOA, specifically TOA. So the tangent of an angle equals the opposite side divided by the adjacent side. And so, for our triangle, the angle is the parallax measurement, The opposite side, that is our astronomical unit. The adjacent side, that is going to be the distance to the star. That's what we're going to solve for. Our known side is 1 astronomical unit. Therefore, we are talking about the distance to the star in astronomical units. And if you will recall, our angle measurement is in arc seconds. Mathematicians have a handy little trick. For tiny angles such as this, the tangent of the angle is almost exactly the same as the angle itself. Now for our formula, just like magic, we can safely replace tangent of the parallax with simply parallax. This will simplify our remaining calculations with no impact on accuracy. Small angle approximations are proven to work with radians. So let's convert arc seconds into degrees and then degrees into radians. We recall that 1 arc second is 1/3600th of a degree. 1 degree is pi divided by 180 radians. So let's plug that into our formula. We can crunch all of the constant numbers together and rearrange the equation so that we are solving for our distance in astronomical units. And we can see that is 206,265 divided by our parallax in arc seconds. And this gives us the parsec, an invaluable unit that astronomers use to describe large distances. And therefore, if we solve for our distance in parsecs, it is exactly 1 divided by our parallax in arc seconds. Plugging in our parallax from Alpha Centauri A, we get a distance of about 1.33 parsecs. This is an incomprehensibly large distance. It's about 4.34 light years. That is over 41 trillion kilometers and 25 trillion miles. The parallax method gives us a trustworthy method for measuring the distances to nearby stars. Now, let us return to the Alpha Centauri system and take a deeper dive into the 3 individual components. First, there is Alpha Centauri A. It is known as Rigel Kentaurus. This means the foot of the centaur. Rigel Kentaurus is a main sequence star, similar to our Sun. Next, there is Alpha Centauri B. It is known as Taliman, which means the 2 male ostriches. Taliman is a main sequence star, similar to our Sun. Finally, there is Proxima Centauri, which means nearest of Centaurus. This is because it is the closest star to Earth. Proxima Centauri is a red dwarf. Together, Alpha Centauri A and Alpha Centauri B form a binary star system called Alpha Centauri AB. They orbit around their common center of mass. This is known as their barycenter. One of these orbital periods takes roughly 80 years. Proxima Centauri also orbits the same barycenter. However, It has a much longer orbital period, about 547,000 years. Rigel Centaurus has roughly 1.51 solar luminosities. That means it is about 1.51 times brighter than our Sun. Rigel Centaurus has roughly 1.08 solar masses. That means it is 1.08 times as massive as our Sun. Rigel Centaurus has roughly 1.22 solar radii. That means it is 1.22 times larger than our Sun. Ptolemy has roughly 0.498 solar luminosities. Ptolemy has roughly 0.909 solar masses. Ptolemy has roughly 0.859 solar radii. And now for the baby of the bunch. Proxima Centauri has roughly 0.002 solar luminosities. That is much less than 1% the brightness of our Sun. Proxima Centauri has roughly 0.122 solar masses. Proxima Centauri has roughly 0.154 solar radii. Thank you for joining me on this wondrous journey to Alpha Centauri. Always look to the stars. Until next time, friends, have a great day.